Welcome to this video of predicting fantasy football player prices with me, Linus Hakansson, Senior Solutions Engineer at SnapLogic. So I will be showing you how SnapLogic's out-of-the-box integrations for machine learning, Google Sheets, Google BigQuery, and Jira can help create a pipeline to predict player prices and to automatically act upon a certain player's price, for example, if that player could be a valuable option for our team. Before we go into the SnapLogic platform, I will give a super quick introduction to the economics of Fantasy Premier League and how you can win it. We will then take a look at our pipeline that uses machine learning to predict players' prices. And then finally, we will be looking to extend our pipeline to also act on players that are predicted to be undervalued or underpriced by our model. So Fantasy Premier League is the world's biggest fantasy football game. So there's more than 6 million players playing each year. And there's a lot of awards and bragging rights within your family or group of friends or colleagues even. So by the start of the game, you select 15 players that are real life players, and they are priced individually by the official game, and you have a budget that you need to stick with. So you cannot have the most costly players in your side. You have to make some sacrifices and be able to identify which players might be priced cheap and which players might be priced a bit expensive for what value they bring. So players score points by their real life performances. If a player scores a goal or keeps a clean sheet, they will be introducing points to your team. So one key here in the success of your team during the season is to be able to spot the underpriced players and obviously transfer those players into your team and avoid those players that you think are too expensive and will not give enough value for their price. So that's a real key for success playing this game. So how is player cost pricing done in the start of the season? So there's no public documentation or information on how the official game sets the prices of the players in the beginning of the game. However, what is available is statistics such as goals scored and red cards and other player statistics from previous seasons. So what we want to ask ourselves is, can we calculate a machine learning model to predict what the price should be of a player? If that is the case, we might be able to spot which players are underpriced by the game, and in that case we may want to bring them into our side. So the prediction pipeline that we will be looking at first will essentially do the following things. It will load the player KPIs. So again, that is the name of the player, what team are they playing in, what position do they have, how many goals did they score previous season, how many minutes did they play previous season, various KPIs for different players. We will load that information from Google's BigQuery, which is Google's data warehouse analytics platform where we currently keep that statistics. We will then generate a machine learning model that predicts the player cost based on those KPIs that we used as the input. And we'll be using SnapLogic's out-of-the-box AutoML Snap with the HTO, which is an open source machine learning platform, to predict and create a model. We will then take the player prices that we want to predict. So this is going to come as input into a REST API that we will expose. We will feed those players that we want to predict, as well as the model that we have generated, to SnapLogic's AutoML predictor that is using regression to come up with a prediction for the value or cost or price of the players that we wanted to predict. Now, when we have a result of the prediction, so what is, according to the model, the predicted cost for a certain player, we're going to merge that with the actual input that we had in going into the model and respond back to the request. So the result of this pipeline will generate essentially a JSON document or JSON array with all the players that were sent in the input, but for every player there will also now be a new JSON key, which is of course the predicted price for that player. So we're now in the SnapLogic designer mode where we already have a pipeline for predicting player prices. So on the bottom left here we have the Google BigQuery execute snap. This snap performs a SQL query towards the BigQuery service and returns the data in the dataset. So we can just quickly inspect how the dataset looks like by exploring the Google Cloud Platform BigQuery user interface. So as you can see here, we are fetching all rows from the datasets and they are presented in a nice results table on the bottom here. So coming back to our SnapLogic pipeline and specifically the BigQuery snap, we can see that we have configured the exact same query. So the one that returns all the KPIs from the dataset. When I set this snap up for the first time, I configured the BigQuery account with OAuth token information so that it is able to authenticate against the service. So the resulting document here is fed into an AutoML trainer that uses the HTO engine or machine learning platform to generate the model. We have selected the label value to tell the engine which field we want to be able to predict. So the value here is the cost or the price of the player that we want to predict. So this snap generates a model, which is then taken as input to the AutoML predictor snap. So however, the AutoML predictor snap requires two inputs. So the model that we just generated is the first input, but the second input is the actual array of all the players for which we want to predict the cost for. So on the top left here, we have a copy snap. So what the copy snap does is that it takes all the input and duplicates it into two outputs. So in SnapLogic, leaving an empty input connection, as in this case with the copy snap, will direct any incoming HTTP post content to its input. So in our case, for the REST API, that will be a JSON array as input of all the players to predict the cost for. If I was developing this pipeline from scratch, I would probably connect the input of the copy snap with a JSON generator snap. In that way, I could feed the copy snap with hard-coded JSON data of the players and get a live validation of my pipeline during the development. One of the two copies of the copy output is sent as input to the AutoML predictor snap, together with the actual model. So the output of this will be a JSON document containing all the predicted values or the cost for the players sent in the HTTP post request. In order for our pipeline to respond back to the request with a nice response containing the original input combined with the predicted values, we're using a merge snap to combine our two JSON arrays. Remember that leaving a pipeline input as empty, which we did with the copy snap, directs the HTTP post content to the snap input. So in the same way, leaving an empty output as here for the merge snap directs the output of the snap to the response of the HTTP request. So let's try this out by actually using Postman to try out our API or our pipeline in this case. So I have the URL here for my pipeline for the REST endpoint, and I have the body content of the JSON document here. So in this case, I'm not going to send an entire array. I'm just going to send one player that I want to predict the price for. So in this case, it's a player from Newcastle, and I'm also passing the actual cost of the player. So this is not the actual number that we will get back from the prediction, but we need it anyway so that we can easily compare if the actual cost is similar to the cost predicted by the model. So I'm just going to go ahead and make this HTTP post request, and let's see what response comes back. We're now going to respond from our pipeline that the actual cost obviously was still 4.5, but the predicted cost of the player was 4.77. So quite close to the actual cost of the player, which might indicate that there's no immediate action that we need to take on this player to get into our team. Before we move on, let's recap on what we have so far. So we have a pipeline that dynamically fetches the latest KPIs from a dataset in Google BigQuery. And every time that pipeline runs, a new machine learning model is created based on the latest data. And we have a REST API that, when invoked, will take the players presented in the HTTP post body and pass through the pipeline with the machine learning predictor and respond with the players' predicted costs. Now, imagine that we are someone else, maybe a colleague in the BI department of this fantasy business, and that our goal is to be able to create some business value. Let's say actually we want to make transfers and select players for our Fantasy Premier League team. We can actually reuse the existing predictor pipeline and embed that flow inside a new pipeline. And instead of receiving players to predict in a REST API, we instead have access to a simple Google Sheet for some of the players that we want to predict the cost for. So our end goal is if a player is predicted to cost more, according to our model, than they actually are praised in the game, we want to have the pipeline automatically generating a Jira ticket for us to bring that player in our team. So back in SnapLogic, we now want to create a pipeline to do this. So the first thing we want to do is to read data from a Google spreadsheet. So we already have a Google spreadsheet. So this is inside my Google Drive. It's called FPL KPIs, and inside that there is a sheet called Predict. Now it includes some of the players that we would like to predict. So the name, the team, and some of the KPIs. So back in SnapLogic, we want to use the out-of-the-box Google spreadsheet snap in order to read that data. So I'm going to go ahead and search for Google and drag and drop the worksheet reader. Now the worksheet reader, when we go ahead and configure it, first of all, lets us select the account for which we want to authenticate with Google. And I've already configured the authentication to Google, so we don't have to worry about that. So for the settings, I'm first of all going to make it have a readable name. So I'm going to name it Sheets Reader. And since I'm now authenticated to my Google Drive account, I'm allowed to just go in and find all the spreadsheets inside my Google Drive. So in this particular case, it's going to be FPL KPIs, and the spreadsheet within that is called, or rather the worksheet is called Predict. So I'm going to go ahead and save that. Now, with the live validation capability of SnapLogic, I'm actually getting what the outcome is of reading these Google spreadsheets. So I can see here that we have a JSON array describing what the players that we want to predict look like. So the next thing we want to do is to execute the pipeline that we have covered in the previous step and feed it the spreadsheets information that we got from Google. So I'm going to head and search for pipeline to get the pipeline executor and drop it until the Google Sheet Snap. So when I configure this, I first need to configure what pipeline I want to execute. So in this particular case, it's called FPL Predictor API. Now I get to choose what SnapLex I want to use to execute this in, and I'm going to use my shared CloudPlex one in my trial environment. Now, another thing I want to do is I want to change the snap execution from validate and execute to just execute only. So this means that while the live validation of my pipeline is a great thing, in this particular case, it might take some time to actually validate the step where we invoke the other pipeline, as it will actually retrain the machine learning model. So in this particular case, I'm letting that be turned off. So what's going on so far in our pipeline is that we read a document from Google Spreadsheets and we feed that document as the input to our other pipeline, which is the FPL Predictor API pipeline. Now that's going to go ahead and train a machine learning model and predict the costs for the players that we have fed it. It's going to respond with an array of all the players and their predicted costs. So that's going to be the outcome of this particular snap right here. So on that outcome, we want to take an action. So either if the predicted cost is higher than the actual cost, we want to create a Jira ticket. If it's not, if it's equal or less, we want just to ignore it. So we essentially need some way to route different logic into different actions. So what we want to do is we want to go in and look for our different flow snaps here. And in this particular case, we're going to use the router one, which lets us take one input and based on an expression, route the outcome to different parts of our pipeline flow. So if we go in and configure this router, first of all, I want to give it a meaningful label. So I'm going to say check if bargain. Now we can create and configure a number of different output alternatives based on how many different ways we want to execute the flow. In our particular case, we only really have two. So we have player is bargain, or ignore if it's not. So going back to our expression setting here, we essentially only want to really care if the player is a bargain. So how do we know if a player is a bargain? Well, you could say that if the predicted value, so this is what our previous pipeline will come back with as the value of, or actually the predicted cost of a certain player. If that is larger than the actual cost of the player, then we are very interested and we want to associate this player with being a bargain. So we're going to save that and dismiss this dialog. And now, as you see, we have kind of two different options here. Either player is a bargain, and then we're going to go on the top right here with the flow, or we're just going to ignore and not take any further action on this particular player. So the last part of, before we actually create the Jira ticket, is to make a mapping between the input data and the data needed for Jira to be able to create a ticket. So of course there's an out-of-the-box snap for Jira. So I'm going to search here for Jira create, and I'm going to head and drag and drop that for here for a while. Before we actually attach it to the snap here, we first want to use a mapper in between to set the different properties that the Jira REST API that the Snap is using is set correctly. So just quickly before we go ahead and do that, let's just examine the Jira create Snap configuration. So first of all, the default selection here is that Snap execution will happen only in execution mode and not in validation mode. And obviously this is because we don't want to create a massive amount of Jira tickets every time we validate and develop our pipeline here. So the second part is, which is automatically selected here, my Jira authentication account here. So we are actually allowed to perform operations towards the Jira REST API. So back into the mapper. Now, the goal here is to map the parameters that are coming into the mapper, which are obviously related to the KPIs and the predictions of the players, with the outbound parameters, which are related to what will be sent to the Jira REST API. So that will be things like what type of issue are you trying to create, what will be the summary and the description of that particular Jira ticket. So we're going to add a new binding here, and for the thing going into the Jira API, in this particular case, it's going to be fields.issueType.name. So that is the type of issue we want to be creating in Jira. In this particular case, we're going to hard code that as task because we don't want to create an issue or a story. We want to create a task that can be consumed by whoever is managing the Fantasy Premier League team. The next thing we want to be able to do is also to hard code another parameter, and it will be the key of the project. So the key of the project is the identifier of this particular Fantasy Premier League project that I have set up in Jira. And this will be Snap. So that's another hard-coded string that I'm going to pass to the API. Next, I want to define the title of the Jira ticket. So that is basically what is being described in the header or summary of the Jira ticket. So the actual Jira field for this is fields.summary. And I'm not going to really hard code this one. I'm going to actually reference the name of the player that we want to suggest a transfer for. So I'm going to stop by saying make a transfer for, and then I'm going to reference the parameter that we have available, or the variable that we have from the incoming JSON document, which is the name of the player. Great. So last thing is we want to reference the Jira field called fields.description, which is a bit more, oops, sorry, wrong character here, fields.description, which is the more descriptive metadata for a Jira ticket. So in this case, we're gonna be a bit more specific of why we would create this Jira ticket and why we should make the transfer. So we will be first referencing again the name of the player. So name has a predicted cost of, and now we're gonna reference the actual cost of the player, or not the actual cost, but instead a predicted value of the player. So that will be from the pred variable that we got from the AutoML snap. And then back again to our string. So compared to the actual cost of, they're going to reference the actual cost, which is obviously in the variable called actual cost. And now we're going to head and just say, make a transfer in the FPL game to emphasize that we should really start hitting that. So that's all the fields needed. Obviously, there's a possibility to add more details to the Jira ticket, but this is essentially the most necessary parts for being able to create the Jira tickets. So I'm going to go ahead and save that. And that should be everything that we need in order to try this out. So in a real case, we might be able to extend this or modify this pipeline so that it can be created or invoked as a task, which means that we could, for example, set a schedule to run this every midnight or something to potentially create Jira tickets in case there's players to transfer. But for now, after this has validated, we're going to run it and we can actually go in and see in Jira if it has created a ticket. All right, so let's go ahead and execute this pipeline to see what it actually does. So while this is running, let's just do a recap on what's going on here. So first of all, we're fetching the data for the players that we want to predict from a Google spreadsheet. We take that JSON document that we got and we push that into the pipeline that we have covered before in this video. Now that pipeline, of course, will go ahead and train a new machine learning model based on the latest KPIs and statistics from the BigQuery dataset. And then it will make a prediction using the AutoML snap from SnapLogic on that prediction, or sorry, on those players that we fed into it from the Google spreadsheet. Now it's going to come back into this pipeline with a JSON document describing all the players that we want to predict the prices for, as well as their predicted cost. Now, using this router, we then look if the player, so we essentially do that for all the players, if a player is a bargain or not. And we have an expression that essentially says that if the predicted cost is larger or greater than the actual cost, then we're going to consider this as a bargain. If it's not, we're going to just go to the ignore output here. So considering or assuming that it is a bargain, we're going to use the mapper to translate some of the values that we got from a player's metadata or KPIs and information to the Jira REST API that lets us create a new Jira ticket for that particular player. And there we are. So according to what we see here in the pipeline, it's all looking green and good. So let's go into our Jira project here, where we have our open issues or our task for the Snap FFPL project. So I'm just going to do a classic refresh of the browser here, and we can see that we have a bunch of new tickets being generated for us. You can see that they were just created 22 seconds ago. So for example, make a transfer for Sacco. Sacco has a predicted cost of 5 compared to the actual cost of 5. So obviously in this particular case, the player price was extremely similar to the actual cost, or the prediction was extremely similar. So it's not really going to have an impact. So we could refine our logic by having, it needs to be larger than 10% or something like that to have a bit more margin for when we should do a transfer. But if we'll have a look at another player, for example, Morgan here, we can at least see that this player was predicted to cost 4.9, but the actual cost was 4.5. So here we have almost, a 10% difference, which is a bit more interesting for us to make a transfer. So in the beginning of the video, we showed how we can have a powerful pipeline to use AutoML and machine learning to predict a fantasy Premier League player's cost. So we fetched KPIs and information about players from Google's BigQuery platform. Then we used the AutoML components of SnapLogic to create a machine learning model. We then exposed our pipeline as a REST API and fed players that we want to predict into the pipeline. And as output, we got a response with the players as well as their predicted prices or cost according to our model. In the second step, we looked at how can we reuse this existing logic and this existing pipeline to create a new business logic and potentially new revenue streams or new use cases for our business. So in this particular case, what we wanted to do was to get a prediction result from our existing pipeline, and if that result came back as a player being overpriced or underpriced, if the player was underpriced, we wanted to create a Jira ticket in order to let people know that we should probably have a look at transferring this player into our fantasy Premier League team. So that is all for this video. I hope you enjoyed, and thanks for watching.